Hi there. We continue Quality Engineering Day 2023 that is conducted at the Global Testing Community and Pro-Quality Community. So thank you for staying with us, and we proceed to the next talk. Our next speaker is Yury Kastyrka, Lead Software Test Automation Engineer at EPAM Systems, with topic, what if your chatbot tests could write themselves? So don't forget to raise your questions in the chat, and we will discuss the most interesting ones at the end of the talk. So make note that session is being recorded, and the recording will be available in a week after the session. So hi Yury, pass the word to you.
Hello everyone. So can you see my screen, by the way? Yeah, cool. So hello everyone. Today we will speak about chatbots and how they can be tested. Well, everyone knows you should test thoroughly. Everyone knows you should have automated regression tests. And everyone knows that tests take time to write. Lots of time. But what if they didn't? What if every time the system changed, it could automatically generate and run a new set of tests without any human assistance? That's what we built for a big UK telecoms customer as a part of their chatbot solution, and now forms a key part of the conversational AI platform we are offering to new clients. My name is Yury Kastyrka. I am lead software test automation engineer at EPAM, and I'm going to describe why chatbot testing is so challenging and how we built our solution. To start, let's look at the results which we have delivered for the client. One that I would like to mention in particular is the Net Promoter Score, which measures how likely customers are to recommend you to other people, showing that when you get chatbots right, customers really like them. We also helped to dramatically decrease cost, reach a high rate of intent recognition, and improve other important business metrics. Before we move on to the solution, let me explain a few of the main concepts about chatbots. I believe almost every one of you has used a chatbot to solve some everyday tasks and knows what they are from the end user point of view. But let's look at how it works inside. Chatbot is powered by a natural language understanding engine, an NLU, which can be through of as a virtual angel that understands what a human says in text messages or voice, processes it, and then return an answer or takes an action based on what the person wants. Every time a user starts a conversation with the bot, a session is created and will be used till the end of the conversation. The key concept is the intent, showing the user's intention in the current message. For example, if the user wants to ask for tech support, then the tech support intent could be implemented and triggered for this turn. Alternatively, a user would like to check something about his bill. In this case, the account billing intent would be triggered. Also, some NLU engines use the concept of an entity um, to obtain one or more parameters from what the user said. For example, the kind of phone that user want to upgrade to, and then use those to adjust what the bot says or does in response. Okay, so let's see if it's possible to test chatbots in depth, which challenges we can meet, and how to apply test automation here. The first question that comes to mind is how we can support high testing quality for complex bots, which have tens or hundreds of intents and transitions between them. How can we make sure that our bot is smart enough to handle unexpected queries from the user? Is the bot able to quickly handle hundreds or thousands of user requests simultaneously? Also, how long will it take to update and add new test scenarios because of frequent designers updates if you have a chatbot with a huge number of user journeys? And finally, how to ensure you have a high quality product without requiring a huge QA team. Let's take a closer look at the chatbot in terms of its internal structure. A chatbot can be represented as a state machine and considered as a directed graph, as you can see here. In this case, each node will represent a certain state in which the user can currently be. Let's imagine we have bot is only 4 nodes. In this case, we have just 3 possible paths which a user can follow. But if we just add one more node, it leads to double its number of paths. And what if we add just a loop from the end to the start node? Now it's become difficult to calculate the number of paths. And what if we add just a loop? And that was just a simple hypothetical case. How can you determine the number of scenarios to cover all possible journeys for real bot like this one? And by the way, this is only one flow from the chatbot. If, for example, you use platform like Dialogflow CX, you can have up to 20 of these. Furthermore, the logic of transition between nodes could be different. For example, it could be triggering the intents. Some condition might depend on parameter values, various event handlers, the results of webhook calls, and more. Here is just one example of a more detailed view where designers can modify what bot should say to the user with quick replies, buttons, links to external resources, transitions between nodes, and so on. Given the difficulties that I have described now, our team has developed a test strategy and defined the testing types which should be applied for comprehensive testing. Well, we have defined the next testing types there. Analytics, end-to-end, performance, regression, release, and security. Let's start with regression testing, which allows you to test all possible journeys within the bot by generating test scenarios using similar phrases to one the bot has been trained with, and making sure you haven't broken anything. Analytics help us understand if our bot is smart enough and able to handle unfamiliar and unexpected phrases from the user by using data science techniques to generate complex scenarios. To get insights about the chatbot's performance, we need stress and load test. We need security testing with special phrases because prompt injection is a threat to ensure that the bot behavior will be safe and predictable. End-to-end will allows us to integrate the above testing types into CI/CD pipeline to ensure a continuous process of product testing. And finally, release testing activities, including end-to-end, smoke, and sanity test, enables us to support high quality of product even in case of frequent releases. Let's talk about what targets we had with our testing approach. So we want to reduce the testing time for release for a complex bot for from 1 week to just 1 day using one QA. We developed a testing approach which allows us to automatically generate all the required test scenarios, which lead to minimizing time for it to almost zero, just over 2 minutes, rather than writing them all manually. Having scenarios which are always up to date allows us to significantly decrease the test run duration and the time for investigating failed tests for both regression and analytics testing. All of this means we could continually test a complex bot without hiring a huge QA team to support all the stuff. Quality metrics are also important targets. So the regression test pass rate for each release should be 99% or more. Analytics testing pass rate should be not less than 70%. So you know that your intent recognition is good and able to correctly respond to unfamiliar phrases. And last but not least, we need to check the performance. This is also an essential type of testing, since the response time on the bot to the user is critical, and if it doesn't respond quickly enough, the client can think it failed and simply close the chat. So let's look at the possible solutions that we considered. For example, using some ready-to-use tool from the market or developing our own framework. First of all, I have to say that we originally did this analysis 2.5 years ago. At the time, there were several solutions on the market. The most well-known was Qbox, a paid solution, and Botium, which has a free basic version. The issue was that we needed a solution which could support the types of testing and key metrics that I have just described, such as the possibility to automatically generate tests instead of creating them manually. None of the existing solutions that were available could do everything we needed, so the answer was to create a custom solution by ourselves from scratch. After more than 2 years, we can see that our decision was the right one. If you look at the most expensive version of Botium, you can see that they are moving into the same direction. At the same time, we have the advantage in that we work with the real customers within the pre-sales activities, where we hear what they want, we get real feedback, and as a result, we can continue to manage the product development in its appropriate way. Finally, let's go to the technical details and look at how we built our solution. Firstly, let's take a bird's eye view on the architecture of the test automation framework. Here you can see two main components, test generator and test runner, which will be discussed in more details afterwards. Speaking about the technologies for the solution, Python has been chosen as the most popular language among data scientists who we work closely with. For performance testing, Gmeter was selected as it is the most commonly used using in this area. If you look at the components which we initially integrated with, you can see Botmock. It's a chatbot conversation design tool, and Dialogflow Essentials. It's a Google basic platform for chatbots. Botmock was used by our conversational designers, but at the end of 2021, it was bought by Walmart, who then stopped developing and supporting it. That was a real challenge for us, since at that time we had a quite big bot that needed to be maintained and developed further, but it also proved that our decision to build a custom solution was right. Because we could no longer use Botmock and Dialogflow Essential was impossible to manage without it, we made the decision to move to Dialogflow CX. It's more expensive. Let's proceed. So there were two big challenges that we had to solve for migrating the bot that was already in production. The first one is that Dialogflow Essentials and Dialogflow CX are very different in the concept of building bots. For example, Essential is based on contextual connection between intents. NCX is based on transition states. The second thing is that the developers and conversational designers had to retrain their skills from botmock to using the Dialogflow CX editor instead, which is completely different. Also, our performance test communicated with a live person, which is a client's integration point between the chatbot, end users, and human agents. Not everything went smoothly, but we were able to manage it. We achieved the desired metrics and found and fixed critical defects in their product, which was fixed before product went live. So let's look at the test generator architecture from a high-level perspective. Firstly, we need to export the structure of the chatbot itself. For Dialogflow CX, that includes all states. In CX, they are called pages, intents, training phrases, entities, transition roles between the pages, event handlers, and so on. After that, the enrichment process starts. This is a data science component which produces more phrases for the intents using various approaches, as I will describe in a moment. The next step is to launch the test generator itself. As an outcome, it will generate test scenarios for the bot. Let's take a closer look at how it all works. As I just said, we need a bot expert and some generated training data. However, that's not enough for the data scientist model, and therefore real conversational history from the end user is also used. Now it's a turn of machine learning and natural language processing. Using various approaches in the enrichment process, for example, translating phrases from the source language to some other and then back to original one, or using database of synonyms allows us to get huge number of new phrases. These phrases are divided into two non-overlapping sets. The best of them, according to the model perspective, are used for training the bot itself. And the second one is applying for testing the bot. Finally, based on the bot definition and the sets of phrases, we generate the test scenarios for regression and analytics. Now it's time to look at what the test runner is. As you may have guessed, the scripts are generated in BDD format using Gherkin language of given when then. What is the main reason for this? Firstly, it allows us to generate scripts from the code in a human readable format. Secondly, it naturally combines with the dialogue between the end user and chatbots. So, the first component of the runner is a code implementation of BDD steps which are necessary for testing. Second component includes integration with third-party systems such as Dialogflow. It's necessary in order to send user utterances to the NLU engine and receive back a response object containing all the necessary data for validation. The third component is logging and reporting models, which are needed for investigating failed scenarios and generating test run reports. And now a bit of magic. This is a real generated scenario of a test bot for renting a car. First of all, here we can see a step that allows us to send a given utterance to the bot. Next comes the various steps of chatbot response validation. The intent validation shows if the bot correctly recognized the user's intentions in his or her query. State indicates whether NLU engine correctly made a transition from its previous state to the new one. In the fulfillment section, we are checking that the expected message from the bot or payload can be used to display quick replies, buttons, links, and so on to the user. The parameters section can be used for extracting some entities, for example, from the user utterances, and can then be applied in the next steps for checking conditions or generating a response message to the user. Finally, we get a full end-to-end scenario that describes one of the user journey. Well, finally we reached the conclusion, and we can have a look at the time savings all this generates. Let's have a look at the time estimation for one test run for both regression and analytic testing in scope of a release which we did on a real project. So for manual regression testing of 600 scenarios, it would take 30 man-hours for test execution and the same amount of time for the result investigation. For manual analytics testing of 750 scenarios, it would take accordingly huge number of man-hours for the same operations. As a result, we can state that for 1,350 scenarios, we need 135 man-hours. Below, we provide the approach to how these estimations have been calculated. And now, let's look at the actual results we got thanks to the automation of the same scenarios. Regression testing now only takes 1 hour for all operations. For analytics testing, it takes a little more than 1 hour. So, in total, automated testing for both regression and analytics now takes only 2.3 hours of time instead of 135. Also, just a note that this estimation don't include time for defect reporting and creating test scenarios. An important point about our test automation framework is that it's a unique end-to-end solution fully integrated into CI/CD processes which supports the next stages. Regression testing to support chatbots behavior validation. Analytics testing, which enables smartness evaluation of the bot. Followed by performance testing, including stress and load tests. Then security testing with vulnerability checking. And finally, all the stages allow you to release a comprehensively tested product. So, regression testing allows us to generate test automation scenarios based on chatbot structure for validating its behavior. Validate any attribute in chatbot response. Decrease the time of for regression manual testing. And more efficient investigation of failed and test support scenarios. The next, analytics testing allows us to generate advanced test optimization scenarios with testing utterances for evaluating bot smartness. Also, we do performance, stress, and load testing support. Security testing means we generate additional test optimization scenarios with special utterances to check for chatbot vulnerabilities. And finally, the QECD pipeline with end-to-end testing. So, summing up, I can say that it was a challenging but rewarding experience. But that's not all. The story continues with our internal project, the PAM conversational AI platform called AIDA, which we are currently developing further and offering to the clients as a part of pre-sales activities. Let's look a bit at the main benefits that our platform will offer as a result. The first one, AIDA can support any NLU engine, giving you the flexibility to use the engine that works best for your business. Its automated testing capabilities ensure that your bots are functioning properly, saving your time and money on manual testing. The low-code conversation builder makes it easy for anyone to create bots regardless of technical expertise. AIDA support a wide range of integrations, making it too easy to connect with the tools and services you're already using. If it's got an API, we can talk to it. AIDA can also integrate with large language models such as ChatGPT, enabling you to manage all your bots from a single location. It's built on open standards, ensuring that you are not locked into a single vendor. With AIDA, you can get started within the days, within not weeks. Our message transformats allows you to transform incoming messages to a format that works best for your bot. In summary, AIDA combines the power of classic chatbots with the latest ChatGPT features, giving you the best of the both worlds. And to wrap up, Let me show you just a couple of screenshots of the AIDA platform. The first one is bot management. It allows you to support multiple bot and environments in convenient way. The next one, it's a release manager, enables you to configure and run CI/CD pipelines, including taking a snapshot of the bot, deploying to a test or production environment, manual approval, and of course, generating and running automated tests, which I just discussed. Next one, it's a monitoring center. It allows you to track the necessary technical and business metrics and respond to them in a timely manner. Finally, our platform can be integrated into mobile web and mobile app version. There you can see the real screenshot. And the last slide. So thank you for your attention. If you have further questions, you can contact our team representative and we will be happy to talk to you. Last but not least, I'd like to say thank you to the people who contributed to this presentation. Thank you a lot.
Thank you, Yury, for your presentation. It was great, especially part with AIDA. I really like it. So we have a few questions, and I guess we have time to discuss them. What do you think? What is the future of chatbots?
Thank you for your question. It's a really interesting one. And so for now, as I just told, before ChatGPT, mostly in the world, we used, let's say, some kind of classic chatbots where we have this entities like states, intents, and so on. But I believe with ChatGPT, it will be completely changed in the nearest future. And from our side, also, I should say that we, within AIDA platform, we already started work on implementing ChatGPT features. And also we started work on testing strategies. So we currently trying to develop test approach, how it could be tested, because the main question is when you use ChatGPT, the main question for testing will be what data, what information bot should not provide to the user because of some, let's say, private reasons.
Okay, thank you for your answer. So I guess we're almost out of time. So thank you guys who are watching us right now. So, and if you have any questions, you can leave them on agenda page and we will answer them. So in chat, we have links to our social media and communities. So don't forget to check them. So stay tuned. See you on the next talk. Yeah.